Welcome to my talk, Navigating the Transit Data Landscape. How many of you took the train or bus here today? Nice, excellent, good job, love to see it. And how many of you are already familiar with transit data of any sort? Yeah, oh wow, that's a good chunk. I love to see that too. All right, well, I'm gonna start off a bit with some info about myself. Who am I? And it's because there's a lot of stuff I like to plug because I'm involved in a ton of things. So first and foremost, I work for LA Metro. I'm the tech lead on the digital experience team, which is part of our customer experience department. My background is as a software engineer. I am a public transit writer, and I have been for, my entire career, my entire adult life. I'm an urban explorer, civic tech nerd, multidisciplinary crafter and musician, and generally inquisitive person. A few of the things that I'm involved in that I want to plug, since I have this platform, is MapTime LA, which is a great meetup group and community for mapping enthusiasts. So we teach open source mapping tools, and we contribute to open mapping projects on OpenStreetMap, like Open Sidewalks, which is one that we're currently working on right now. So check us out on meetup.com. Data and Donuts, which is a monthly breakfast lecture series where we highlight local government tech and data projects. And then a couple events coming up that are annual, the LA Arts Datathon, which brings together the arts and tech communities, and then the International Humanitarian Mapathon, where we teach people how to contribute to hot OSM and humanitarian mapping efforts. And then finally, as of last year, I'm also on the board of directors of Mobility Data, and if you don't know what that is, I will get into that later on in this presentation, so just hold that in the back of your head. I need to mention it here, but I won't get into it right now. I graduated from Berkeley in electrical engineering and computer science in 2006. I spent 13 years at the County of Los Angeles doing systems analysis, web development, database work. And the past 4 years, I've spent at LA Metro getting neck deep in transit data and the world of transit data and technology. So this is what I want to share with you all today. What I do at Metro, in summary, advocate for rider information needs inside the agency, improve the way that our digital information reaches riders, advance data standards in the transit industry, and pilot more sustainable tech and data practices at the agency. And all of this with varying degrees of success, because it is a bureaucracy, there's a lot of barriers in place. It's an uphill battle, but this is what I do. And a few caveats here. I want to set the framing right. I am not involved in operations. Those are the people who run our service, who determine what our service is, who make sure that all the buses and trains run as on time as possible. I'm not involved with the hardware or the data infrastructure for that matter. I'm mostly on the public-facing side of things. Definitely not involved in service or planning, but I do like to ask questions, I like to learn, and I like to share, hence why I want to share everything I've learned in the past 4 years with you here today. And so, and in talking about transit data, what do I mean? So, how many of you are familiar with what this is? Yeah? Okay, you've seen this before. These are timetables. We print them out on paper. We put them online as PDFs. This is what our schedulers and planners work on to let the public know what our service looks like. We also have real-time data. So the buses and the trains have sensor technology incorporated in them that lets us know where they are. And then some stuff happens, a ton of stuff happens. It's a long process, but it ends up in your hands, in your phone, through these apps. You can see our schedule info, you can see our real-time info, where these buses and trains are in real time or not in real time, where they're supposed to be at what time, right? So how we get from there to there. and what happens in between. And there is a lot. There is so much, and I worried putting together this presentation that it was too much and at the same time too little. It's really hard to really encompass all of it. So think of this as like you're dipping your toes in the water. It's a long journey, and I'm going to cover a lot. I won't be able to get super in-depth into any of it, really, but if there's any part that you are particularly interested in, want to hear more about, have questions, keep that in mind and ask at the end, because there's so much more that I won't even be able to get to within this presentation. So, our first stop, generating the data. And that starts in our operations department with our service planners and our schedulers. A lot of factors go into planning and scheduling. And first and foremost, a note that I promised my operations people that I would let everyone know is operator is the preferred term for our drivers, bus drivers and the train drivers. They are called operators. So anywhere you see it say operator in this presentation, that's who I'm referring to. So operator safety and experience is a super high priority for our agency and is a big factor that goes into the planning and scheduling that we do around our routes. Some of the important things to call out is, they want to make sure stops are in safe places, that we minimize the possibility of accidents, and that gets impacted by how long a trip is that an operator has to drive and their familiarity with the route. If we're constantly switching the route on them, changing it up, that's a recipe for more accidents. And then really, really important for them too, access to essential amenities like bathrooms. You're driving a bus all day long and you want to be able to have access to bathrooms. So where are you going to go? That needs to be planned out, that's factored in, and it really dictates a lot of things. Community, of course, feedback from the community, looking at things like changing traffic patterns, commercial and residential developments, how much we expect this particular route to be used, and how it connects to other existing routes in the region from other agencies, so not even just our own service. We have to communicate out to other agencies, figure out where they are planning to change their routes, and then coordinate all of our service so that it makes sense on a regional level. And I know LA Metro is the big player in LA, but we have actually over 50 public transit services in LA that operate. Additionally, there are physical limitations, and of course this makes sense, but I didn't even think about this until I started working at Metro. They have to choose routes where the street is actually wide enough. They have to make turns where the intersection has a big enough angle for the length of our buses. And we have different length buses. And so depending on what kind of bus they intend to use on that route, whether it's a 40-footer or a long boy, they're gonna have to choose which intersection to make that turn on. Efficiency, this is of course a big one as well. A lot of planning optimizes for cost benefit and how we efficiently allocate our resources. Part of that is, people run these buses. The people need to get to where the bus will operate. And how do you get that person to where that bus will start? That's going to be non-revenue dead time, and it's not going to be efficient if our operators, have to travel all over the place just to even start their shift and run the bus. So there's a lot of optimization of where staff is along these routes as well. And of course, we want to run the most amount of service that we can for the least amount of cost so that we can maximize how much service we offer to the public. Another important thing is, near side versus far side stops. Planning likes to prioritize far side stops because you've passed the signal at that point. If you stop before the signal, then you might get stuck behind a red light. And so that's one of the efforts where they've been trying to move these near side stops to far side to make the routes more efficient. And then we have, let me see, is this the, yeah, okay, final area, topic, category here, jurisdiction, another huge important one, like I mentioned earlier, where, bus drivers need somewhere to use the bathroom, and that depends on agreements that we have in place. It's the same with where the bus runs, where the stops are, where the buses lay over, because the operators need breaks as well. We, Metro, do not own any of the streets in LA County, even though we operate in LA County. LA County streets are owned by either the county or the cities that are in the county, all 88 cities. And so if we want to have a route run through, if we want to put a stop, on this street, or have a bus, sit there and lay over for a while so our operator can take a break, those cities have to agree to this. And that can be a problem in some cities because some of them won't agree to this, and that heavily impacts what kind of service we can provide, how we plan our service, the length of the routes, and all of that. All of that needs to be negotiated. So there's a lot of barriers before we even get to the data itself. But next step, after all that's figured out, we have a scheduling system. It's called HASTIS. It's a product by Giro. A lot of transit agencies use this enterprise-level scheduling system, and it handles a lot of things beyond just scheduling or managing our service. Of course, it does the scheduling, but it also manages operator assignments to routes, service cancellations, because it's changing all the time. People get sick, stuff happens, we have to switch people in and out. Cost optimization, operator payroll functions, and also long-term planning for the network as a whole. So all of that gets put into this HASTA system, and the data from there is exported as GTFS. So who here has heard of GTFS before? All right, sweet. Nice, that's a handful, and I think I know who you folks are. And so I'm guessing you're the same ones who have worked with GTFS before. All right, so for everyone else, this is brand new, which is great, because I love introducing people to new things, especially GTFS, because that's my jam these days, is data standards. So what is GTFS? It is a data specification. So a set of rules defining what a data set should look like for the producers and the consumers. As someone creating the data, I need to know how should I create the data, what data types, what are the possible values, and the consumers then know how to expect that data when they receive it, so that they're building stuff that can use a standardized set of data. But GTFS is more than that. It is specifically a representation of transit service. It is a transit agency service in a machine-readable format. So why does it exist? You could probably guess, but without this data standard, every transit agency would be publishing their data completely differently. You would have chaos. The consumers of the data would have to create custom code to account for every single possibility of every way that any transit agency would publish their service. And as I mentioned earlier, in LA County alone, we have over 50 public transit service providers. So let me take a quick detour from talking about Metro and what GTFS is, and get into the origins. And it's not super technical, but I think it's really important to understand how this came about, because I see GTFS as so important to the public's ability to use public transit as a service. And by understanding it, we can learn from what happened in its development and maybe replicate it in other ways. So we're going to go back in time to 2005, and some of you might recall what Google Maps looked like back in 2005. Very different from what we use today. And it was that year that Google decided to partner with TriMet, which is the transit agency up in Portland. And in this partnership, they had this goal which I've quoted here from Bibiana McHugh, one of the TriMet employees who was spearheading this effort there. They wanted to make it just as easy to get transit directions as it is to get driving directions from anywhere in the world. So this happened at a really opportune moment, in terms of the technological barriers that could have prevented this from happening. TriMet already had their service as data in their scheduling system. It was already in tables. It could already be exported as CSV, so that machine-readable data already existed in some format. It didn't need to be created from analog. That data was already, yes, able to be exported, so that was like huge barrier already in the world of government, and back in 2005 at that. In terms of business barriers, TriMet as an agency already supported open source and open data. They are already publishing open data feeds used by outside developers. Their procurement policies already accounted for open source. So they already had open source friendly procurement policies for a decade at that point. And if you ever hear me talk about government technology work, that's such a huge thing. Procurement is such a huge, huge deal. And then they were able to find a willing partner in private industry with Google Maps. So all of these really led into their success. And it was a success. By the end of the year in 2005, Google Transit launched. Here's a screenshot that I found on the internet. It went live, and they found that it was a huge success. Hits to the site were really huge, even by Google standards. And this was the beginnings of GTFS. So at that point, GTFS stood for Google Transit Feed Specification because of Google's involvement. And Google Transit expands in 2007. More cities, more transit agencies are recognizing the benefits of publishing GTFS, because then Google Transit can show their service, people can get directions, and this is a huge need for transit writers. At the same time, I want to call out 2007 to 2009 is when we see the first iPhone launch, first Android launch, and 4G starts to spread. Some of the key early decisions that they made with this early version of GTFS was to keep the CSV format that was published by the scheduling systems, because they wanted to keep it as simple as possible to make sure that smaller, less resourced transit agencies could still publish this data without any proprietary technology or complicated data standard needs that they need specialized people in order to produce. They also chose to keep the data specification open and free, and make the resulting data free and publicly accessible. And all of this is super, super important. So in 2010, a major shift happens. We get rid of the Google, and we call it general. So it's still GTFS, but now it is the General Transit Feed Specification. And this is because GTFS, it is growing, it's becoming widely popular, but people are concerned that, is this just promoting or benefiting Google products? They want to grow the ecosystem, but they want to recognize that, no, this is being used outside of Google products, and we want the ecosystem to grow outside of Google products. So the name is officially changed to General Transit Feed Specification. Another thing to call out around this time, as it's getting really popular, development starts to splinter off. As different transit agencies have different needs, they're creating their own flavors of this and putting out their own versions of GTFS, and this is starting to become a problem. And so keep that in the back of your head as we move forward to 2011. The GTFS real-time extension is released. So remember, we talked about GTFS OG. It's all based on the scheduling system. That's all just planned service. It's static data. It doesn't change. But we have this huge breakthrough in 2011 where Google and a group of transit agencies partner up to define an extension to GTFS for real-time data based on real-time GPS location tracking. And then Jump forward to 2015, we start to see some consolidation, efforts in the industry around transit data. The Rocky Mountain Institute hosted a 2-day workshop on transit data interoperability. They put out a recommendation to create best practices to grow this space. And so in 2017, we see those best practices published. There is a working group that is convened, and this work continues as they host another 2-day workshop to identify more challenges and opportunities to improve transit data. And so we jump forward to 2019. Remember, I mentioned mobility data. This is when mobility data is established. Now, I don't know about you guys, but the past 4 years have been a blur for me, and it was kind of like a shock when, I was doing my work, and I knew about GTFS and how it's integral to our service and how people write our system, and mobility data was only established in 2019, so the year before the pandemic hit. But this is important because mobility data is basically this nonprofit that was established to oversee the continued growth of GTFS. Before we had a lot of splintering off of different teams, different groups doing their own thing, and they recognized that was a problem in these working groups that they convened. And that working group effort led into the creation of this nonprofit to kind of consolidate it all, to really enforce a governance process, to see GTFS grow, but make sure it's done in a way that the entire industry can agree with and will benefit everyone. So fast forward to today, GTFS is used by over 10,000 agencies in over 100 countries. It's an international data standard, and mobility data themselves, their work has grown as well. So their work now covers not just GTFS, which is for public transit data. It also covers data platforms and tools around GTFS, as well as shared mobility data. So I won't really get into this, but GBFS is the general bike feed specification for bike share, and they also help oversee that and its growth. So next stop, GTFS schedule. So this is the original version of GTFS that I mentioned that gets exported from scheduling systems. It's that planned service information. Metro releases bus and rail GTFS as separate data sets. And this is for a variety of reasons, but if you want to use our data, just note you're going to find them in separate data sets. And they get updated at different frequencies as well. So our rail is updated every weekday night in an automated process. Our bus service is updated during what we call shakeups. And those are usually twice a year in June and December. And then we roll out minor updates on a weekly basis. So a little bit about the shakeups. This is an operational thing, and a lot of this stuff revolves around how we operate our service. So shakeups are when major service changes happen. So major changes to routes and stops. This is also the bus operator's chance to bid on which routes they're going to drive, and often that's based on their seniority, how long they've been at Metro. They get to bid on the choicier, routes, and leave the ones that people don't like for the newer folk. But this is why major changes don't happen outside of the shakeups. So what does GTFS schedule data look like? Again, because they wanted to keep it simple, it is a zip file, and inside the zip file is a series of text files. All right? These ones on the left are the minimum required ones, but because it's grown and expanded a lot, you can see on the right, there's so many more that could be included. So not everyone, not nearly close to everyone publishes the full set of data, but there's a lot encompassed within GTFS of how you could represent a transit service. So I'll go over them real quick. Hopefully it's not too small, but I'm not going to get into super nitty-gritty details of this. I'm just giving you a high-level overview. So agency.txt, This is, it tells you what agencies are in this particular GTFS data set. One thing to note too, each of these files, they are CSV, and you can think of them as tables in a relational database. They have IDs that serve as primary, they have primary keys, and they have foreign keys. So those will come up, I'll call them out over here. So, you have agency ID in here, you have routes. So this is a list of all of the routes that are included in this GTFS data set. So the data I'm pulling here is actually from our current Metro bus GTFS. And then, let's see, stops, list of stops, pretty simple, straightforward. One thing to note is that in the stops.txt, it doesn't, at least for us at Metro, it doesn't represent all possible stops, just the active ones that are represented within this GTFS data set. Since we release it 6 months at a time, it only represents this 6 months of service. Next 6 months, service might change, bus stops might change. Calendar.txt, this tells you the dates that service runs. We separate our service into weekdays, Saturday, and Sunday. And then trips.txt, this starts to get a little bit more complicated now. A trip is a combination of at least 2 stops during a specific time period traveled by a single vehicle. So that's a little complicated, but you'll see on stop times, hopefully that will make a little bit more sense. So stop times tells you the times that a vehicle arrives at and departs from for each stop on each trip. Oops. And so you see in the second column, we've got arrival times, departure times, and then stop IDs. It's not really human readable there, but those are all the different stops along that route. And you see stop sequence, which tells you the order that the bus is traveling. And then we've got a stop head sign, which is supposed to represent like what the bus shows on its head sign, that display at the front of the bus. And this file is over 200 megabytes big, unzipped for our bus GTFS because we have a lot of bus service. And then just a quick little diagram showing you the relationship between these files and the various IDs. And now I'll get into, there you go. A few things to be aware of, because data standards are great, and I love them, and I plug them, but they don't account for operational reality all the time, and you may not realize how or why. So, some gotchas to be aware of if you're planning to use this data. So within stoptimes.txt, there are these 2 fields called pickup type and drop-off type, and that indicates whether or not a passenger can be picked up or dropped off at this stop. So you might look at stop times and see this list of stops and think, okay, the bus serves all of these stops. Not completely true. You got to check these fields and make sure that they are both 0 to be able to say, yes, as a rider, I can get on a bus here or I can get off a bus here. And this could, and because the data in here reflects our schedule service, we may include stops in there that are layovers or terminals that passengers are not allowed to get on or get off a bus at. So that's why it happens. Another thing in stops.txt, easy enough, it's a list of stops. Well, if we look at our rail stops are actually these stations, right? And so there's this whole concept of like these, what are they called? Parent-children stops, because there's a lot of information to represent at a station in terms of it being a stop. You have it as a stop, and so location type, you have stop or platform, and then you have station, and you also have entrances and exits. And this is important, especially when we have like really big stations where you may get in on one street and then get out like 4 blocks later. I don't know if it's 4 blocks, but at least maybe like 2 or 3 blocks, further away. Some of our stations can be pretty big. So the data actually represents the different entrances, and you can see that in the stop name here for 7th Street and Metro Center. The name includes the different entrances, as well as the elevators, and they are related to the parent station's stop ID with that parent station column in the far right. But one thing to note for Metro's data, which is a problem that I am trying to bring up with our operations people, is that we currently do not have separate data points for each side of the platform. What we have is a single point for each platform. So this at 7th Street Metro Center, you can see the very first row and the very last row, we have the platforms for the A&E lines as well as the B&D lines, but you can't distinguish between, each side of the platform. And that's a problem when you want to use GTFS to navigate. So one thing to note about Metro's bus GTFS with our IDs is that our IDs change. They're not persistent between shakeups for route ID and trip ID. And that can be a problem if you're expecting, oh, a route ID, yeah, like that's the ID for the route. ID that represents that route, it shouldn't change. Well, no, not quite. So you'll see it's actually kind of split in 2 parts. The first part is a number that's kind of like the route number. The second part after the dash, that is the HASTIS version number, HASTIS being our scheduling system. So each time they make changes to service, the HASTIS system will generate a new version number, for tracking, and that gets exported with our route ID. And it is annoying, but it can be useful to see, like, oh, is this actually a new data set from this other one I was using, or what? And similarly within trips.txt for trip ID, we have the first part, which I'll get into in a bit, but that second part reflects that shakeup date. So December 2023, that's when this current version of our GTFS was released. So that will change with each shakeup. So then for that first part of the trip ID, it was not persistent before, but within the past few years, because so many of our consumers identified it as a problem, our operations felt forced to create a format for a permanent trip ID. So that first portion should actually be persistent between shakeups. I haven't tested this out, so I can't confirm for you what percentage of the time it persists, actually. But this is how it's broken down. I won't get into it, but they have a whole system for defining what that code looks like. And then we have parent-child routes. So some routes that you may take and may be familiar with may not have their own dedicated route ID. This is one of the most confusing things that I had to wrap my brain around at Metro, and it's like one of the most confusing things that we've had our data consumers complain to us about. But there are many reasons why it is the case. So just to give an explanation of what this is, let me see, do I have it in here? Okay, I didn't, I'll have to figure this out. But anyway, why we do parent-child routes? Let me back up a bit. I don't know why I ordered the slides this way, but okay. One thing that indicates a parent-child route is that in the stop times file, that stop head sign that I mentioned, what shows up at the front for a bus, you'll see in the middle of a trip, it changes. It says 48 Melrose, and then bam, suddenly it says 10 Melrose. And now instead of being on the 48 bus, you're actually on the 10 bus, surprise. And so in the data, you'll see that reflected a bit. When you use a single trip ID for these routes that have parent-child routes, it may not always be the same route number throughout that entire trip. And we also have non-standard route code and destination code fields. So these are not part of the GTFS standard. But let me, okay, so you've got trip ID there, and you can see that they're the same for all of these rows. You've got stop sequence. So these are all sequential stops, one stop after the other. And then we've got stop head sign, like I said before, changes between 43 and 44. And then we throw in these additional fields, route code and destination code, which is just stop head sign broken up. So you can actually reference route code to get at what the actual number of the bus is. So why do we do this? So operationally, it goes back to some of those service planning things that I mentioned at the very beginning. Some of our trips, they change route mid-trip. They change the route number mid-trip to avoid ending that trip where the route changes. So if we set it up where, it's the 48, and then bam, and then suddenly it's a new trip where the 10 starts, we are obligated to have a layover there and provide access to a bathroom. This is like a technical definition thing, what a single trip is. So we stretch the definition of a trip. So the trip is not necessarily tied to the number itself. The trip is just a sequence of stops, and we can change the route number, in between. But if we ended that trip right there, we have to have a layover there, and we need access to a bathroom there. And again, like I mentioned before, some cities won't agree to let us lay over on their street, so we cannot end that trip there. We try to negotiate contractual agreements with local businesses so that our operators can use their bathrooms, but sometimes we can't find one that will allow them to use their bathroom, so we can't end a trip there. Sometimes that means we have to build our own bathrooms, but this impacts how we design our service, and that shows in the data, and it's something you have to account for when you're looking at this data. All right, next stop, real time. This is fun stuff. So, how many of you use Google Maps or Transit app to plan transit trips? Yeah, awesome. So you might be familiar with a screen like this. This is Transit app. And on the left side here, I have got the three different categories of real-time data that makes up GTFS real-time. So that is vehicle location, which is just live vehicle locations of the vehicles, like it says, like literally GPS coordinates. You've got trip updates, so these are predictions. How far away is that vehicle from this stop? Are there delays? Are there cancellations? And then finally, we have alerts, which is a feed that provides a description of a service disruption. So I've pointed out on the screenshots here what these categories of real-time data translate to, right? Vehicle location, when you see like a little icon of a bus or train moving on a map, that's pulling in vehicle location data. When you see prediction times, like, at this Western Century stop, the bus is 0 minutes away, the next one is 24 minutes away. These are all algorithmically created arrival predictions from trip updates, caveat, if they show you the little Wi-Fi symbol there. So some of them will have that visual indicator that tell you the prediction is based on real-time data. Some of them will, if they don't get that real-time data because there's technological issues, maybe, the data is down or they're not seeing it for this bus, they may show you schedule data, and some apps will indicate to you that actually that prediction is just based off of the schedule. It's not actually based on real-time situations. So that's something to be aware of when you're using these apps. It's not always based on real-time data. And then finally, service alerts. Usually that's like, a paragraph. I don't know. Okay. All right. So that's like, a description of like what's going on, disrupting this route. All right. Oops. All right. Time for another detour. real-time tracking for bus. So this is some background info into the technology that we actually use on our buses and trains. So on our buses, we actually have two systems that give us location. ATMS, which stands for Advanced Transportation Management System. This is like a whole suite of smart technologies that include AVL, standard transit industry term, for automatic vehicle location. Now, our ATMS system transmits this location data to us via radio, and thus the updates come every 2 to 3 minutes, and it was fully deployed back in 2006, so we're talking almost 20 years old at this point. We have, thankfully, a much newer system that was installed, which is our Wi-Fi routers. So on the buses, maybe you've connected to the Wi-Fi that's on the buses before. So they'll transmit data to us via cell towers, and those updates are every 2 to 5 seconds. And those were only fully deployed back in 2021. So that's when we really started to ramp up, real-time vehicle location possibilities with our bus system. Now for rail, we've got something completely different, track circuits. How many of you are familiar with track circuits? Nice, okay, all right, more than I expected, which is cool. So track circuits, it's literally an electrical circuit in the tracks, and if the electricity is running through, that tells us, no train, we're good. Once the train enters that track, because it's got like the wheels and the axle that connect the two sides, bam, that circuit's shorted. Now we know, yes, train, there's a train in that segment. So how we can, where we know the train is based on that segment of track, depending on how big that track is, that track circuit is. We know that train is somewhere in there. We don't know where. We just know at what moment it entered that segment. And then once we detect, oh, hey, it's in this other segment, now we know it's left that segment. Now it's in this one. So it is real time, but it's not quite GPS location. And that, it's sketchy. We're working on having more precise location methods, but it's a pilot project. What I've heard in asking operations about this is that, all of the equipment that gets installed on these trains, they have to be federally approved. They have to pass standards. They don't want non-standard equipment getting in there, being a security issue, being a risk. And so that includes GPS location tracking. And so it's been a problem because the standards have not moved as quickly as our technology has in other parts of our lives. So there is going to be a pilot project. It's still going to be a few years. And then here, just a little photo for you of the SCADA system, which is what the whole rail control monitoring system is called. And you can see here, I don't know if you can see from where you are, but this representation of our tracks, it shows these blocks, and that's because of the track circuits. It just tells you where in that block on the track the train is. All right, so a little technical detail on GTFS real-time. The format it uses is protobuf, which stands for protocol buffer, and it's a binary format created by Google to be more efficient when transferring lots of data, and we're dealing with a ton of data when we're talking about real-time. So not as user-friendly as CSV, but a lot of times our real-time providers will provide the data in JSON as well. So that's nice. So here's an example of that real-time data as JSON. And you'll see sometimes that Wi-Fi routers, let's see. So our Wi-Fi routers will send a location as long as the bus is powered. So sometimes you will see, like that top segment, a location without a trip tied to it. And that's a problem because you don't know what route that bus is running. If it's running one, you don't know where it's supposed to be going. And sometimes that's because it's traveling between trips. It's not actually serving bus riders or traveling to a stop. It could just be waiting between trips. Let's see. Vehicle could be replacing another vehicle, and the bus operations control center maybe didn't reassign it properly, or that ATMS system might be down, and that ATMS system is what tells us what route is this bus supposed to be running, what trip is this bus running. Let's see. All right, end of the line. We're finally nearing the end. Sorry, I know this has been a lot. Where do we go from here? More GTFS, more GTFS. It is constantly growing. There is an amendment process for the specifications. You can check them out on the websites. It's really well documented. There is a whole governance process around it. Broadly speaking, if you want to put out a new extension to GTFS, it requires one data producer, one data consumer, a production implementation, and then a series of public votes on GitHub. So it's all done in the open, which is great. And here's a few examples of recent and ongoing extensions. So trip modifications. What this is detour shapes in GTFS real time. Because schedules has been out for so long, like that's pretty good. We're covered with planned service. A lot of what we're dealing with now in terms of the data representation is when we deviate from planned service, disruptions that happen, bus has to take a detour, how do we communicate that? Trip modifications is one of the first steps towards that. Voting closed just a few days ago on the 7th, so this is happening in real time, guys. You can check out the pull request. You can see all the players involved. This was a partnership between Transit app and Swiftly. And the three screenshots you see on the side are the production implementations with the transit agencies that they partnered with. So locally, actually, Torrance Transit was one of the pilot projects. So if you take Torrance Transit and you use Transit app, you will theoretically see their detours in the app. So check that out. We also have Flex, which is an extension for non-fixed route on-demand or flexible transit. And so this is like rideshare, when you try to schedule a vehicle and it comes and picks you up. Yes, like Metro Micro. It is most often used in rural areas. And actually for Metro Micro, we don't actually use Flex. We use a different standard that's called GTFS Lite, which I won't get into, but that's the one that Transit app takes in. And we have Fares v2, which is how to represent fares. And there was a really basic implementation before. In 2022, the V2 version 2, which advances that implementation, got passed, which is great. But it still doesn't have the capability of representing fare capping, which is what Metro has moved to. So we're still waiting on that. Mobility data themselves, they're hiring, check them out. They are also home to more data interoperability things, I guess, specifications, but also there's a big push there for transit data interoperability in general beyond just GTFS. They are hosting an international summit later this year. And you can follow along with what they're doing on the newsletter. You can get involved on GitHub, and they have a Slack where you can ask questions as well if you need help on how to use some of the specification. I do want to call out CalITP, which is a project out of Caltrans. They've been a huge partner for us, and they are really doing a lot of work to make it easier to take public transit across the entire state, including around contactless payments, benefits, and making sure all the transit agencies are outputting GTFS. And then we've got mobility data interoperability principles, which I won't get into too much, but it's this effort that was started by CalITP, and it's basically this declaration that our industry needs interoperable data to advance. We need transit agencies, and we need vendors to buy into all of this. Mobility data has become the new home and is going to continue the work. What is Metro doing? Metro is a partner with CalITP, so we've been supporting their efforts in the LA region. We're also a co-author on these interoperability principles. We are actively looking for partnership opportunities on various extensions, and we try to participate actively on the voting for the new extensions as well. We also internally have a mobile app consolidation working group, and through that effort, we are pushing for more GTFS schedule and real-time data to exist on a regional level. So it's not just Metro, it's not just Big Blue Bus or Long Beach Transit, the big players providing real-time data. We can get a lot of the smaller transit services in smaller cities to show up with real-time data as well. And we are actively advocating for and expanding data standards in the industry. A bunch of more resources for your journey here. I'll post the slides online, and you can get at the links there. So hopefully you don't have to worry too much about catching all of these links. But there's a bunch of tools. There's a whole ecosystem that exists out there. A lot of projects and apps that use data. Shout out to Catenary Maps over here. And Metro's data as well. We have sites where it's available. And finally, thank you to some of my colleagues in operations as well as at Mobility Data for a lot of the information as I was able to share with you. This is my cat muffin. There's my info and my LinkedIn. Feel free to reach out to me. I wish I had more time for questions. But yeah, that's it. Okay, sweet. We do have time for questions. Yeah. Yes.
Hi. Really cool talk. Quick question. If I wanted to grab all of the data for LA Metro and all 50 partners in one place, does that exist, or do I have to go scrape 50 people to do it?
Ooh. So I don't think you can get it as a single download.
Well, no, just a single source.
Just a single source.
Like a single place
yes.
to go to.
So that was part of the stuff I rushed through, so I will go back. Okay, so we have GTFS catalogs. I would say if you're focused on LA area, well, let's see. Actually, I don't even know off the top of my head which would be the best source because they kind of aggregate at a much higher level. So maybe we could create a source that's just LA County. But CalITP, they actually have these monthly quality reports. And I'll open this up so that you can take a look at this. So what's really cool about their site and what they're doing is that they are taking in people's or transit agencies' GTFS, and they're indicating whether that agency has a real-time feed. They're giving you high-level information about the service provided by the agency, and information about technology vendors if they have it. They're monitoring it, and then down here, they're also checking to see if it follows the transit data guidelines that they've produced to make sure that these GTFS data feeds are following best practices. So you can see here a whole compliance checklist at the bottom. And there are very high-level things at this point, but they do have this available. And it's, there are like other databases as well. Mobility Data hosts one that they're building out. There's a company called Interline that runs Transitland, which is also an international database of GTFS.
Thank you.
Mm-hmm.
Is there a push to organize GTFS for algorithms? Because the way it's implemented requires you to go through every single element. Do you know any movements for that?
I don't know off the top of my head, except some of these projects probably have some sort of implementation to address that. So One Bus Away, Open Trip Planner, they all take in GTFS and are ways to provide back that information to riders in a user-friendly way. I haven't been involved on that technical of a level, so I don't really know for sure.
Okay, thank you.
Mm-hmm.
Anyone else? No?
Oh.
Great talk, Nina.
Thanks.
love to hear, bringing open source to open source conference, a lot of the work you're doing in government and clearly sharing that out. So question, as a frequent writer, often in like LA County, sometimes I notice like buses come late or things like that. And so what I thought was really interesting here is the real-time data that's been developed according to schedule. So how does that play out with real-time in the city? So it's like, hey, this bus is late, or hey, we have this happening where we're going to want to send more buses or trains to that. How is this used in like real time to, instead of after the fact or after the day for performance reports in real time to ensure better quality of writing?
Absolutely. So that gets into some stuff that I didn't even get a chance to talk about, but I get to show you guys because lucky for you, I have access. So our real-time predictions vendor is this company called Swiftly right now. And they provide us with this dashboard that we can use to see what's going on in real time. And not only that, it is something that our bus Operations Control Center, our BOC, we call it the BOC and the ROC, Bus Operations, Rail Operations, but they're able to input service disruptions into this system, and that gets incorporated into the data going out because Swiftly is the one who publishes our real-time data. So you can see. Is that manual or is that automated? So some of it is manual, some of it is automated. We do have cancellations that get put into the scheduling system that gets exported as a data feed that Swiftly will take in. So they'll automatically pull those in as adjustments, which you can kind of see here, items that say they're created by active batch. But then some of it is manually created, probably like this closed stop, which is, what is it? Yeah, construction. Yeah. There's start end times, and then, with the moment it's in here, the Swiftly's algorithms will know to account for that and make adjustments to the prediction times that go out to the public and to all of the apps that take in this data. And actually, that's another great thing to call out, too. So you might notice differences in the way that, like, Google Maps or Transit app or whoever shows you prediction times, how many minutes away is this bus from the stop. And on a basic level, they are all receiving the same data. It's all data that's coming from us through Swiftly. They may do stuff to it, like, I don't know, Google Maps may add in like traffic stuff in their algorithm to modify it or whatever. They may do their own changes based on historical patterns that they've seen, but on a base level, all that location data comes from us. There is no separate other magical source where they're getting where the buses and trains are. All right. Thank you.